Marvelous morning, Algebros. This is Mr. Jeffries. We're back with Algebra 2. Moving on in our next unit, we're in quads and vertex form. Okay, so believe it or not, the form that y'all have been doing, this is called vertex form. Okay, because it's easy to find the vertex. I don't know, people did drugs, okay? So, this is what we need to know. That the axis of symmetry is going to be x equals h, and the vertex is hk. Alright, so let's get through this example. Our a value is right here. This would be 3. Exactly, okay. Our h value, remember, h is the opposite of what's written.
Positive.
Alright, now, because h is this, our AOS, axis of symmetry, is going to be x equals 2. The x value for our vertex is also going to be 2 because it says h right here. Alright. Our k value is 1. This goes here. Now, what this axis of symmetry is, it cuts the vertex, cuts the graph in half. I've never liked when people say you have to graph the axis of symmetry. The definition of the axis of symmetry is an invisible line that cuts a graph in half. Why do we have to graph an invisible line? Makes zero sense. All right. So, let's look at this. For number 1, our a value is 1. Alright. Our h, -7. That means our AOS is x equals -7, and our vertex is x value is -7. The reason why I'm doing all this at once is so I don't have to flip back and forth between all the colors. Okay, and what is our k value, May? Okay, and where does it go again? Yes, the y value for the vertex. Alright, number 2. Alright. Our a value is 2. Our h is +4.
6.
And yes, our k value is 6, so it would go here. Now, number 3. What is our a value for number 3? -1. Our h, -6. And our k, -4. Alright. So, now, no, this is not the whole lesson, but it does kind of go kind of quick. Alright. So tomorrow when we do our practice stuff on this, you'll see how it goes. Okay? Alright. Has everybody got all this down right on for 1, 2, and 3? Yes, no, maybe so. Catch the tiger by the toe. Okay. Whoops. Too far. Alright, so when a is positive, the min is the vertex and the max is infinity. When a is positive, it's a smiley face. Okay, that's why that is. When a is negative, it's a frowny face. That means the max is the vertex and the min is infinity. Okay, like if I were to pick one of y'all up and throw you across the room, it would make an arc, and the vertex would be the highest point right here.
I volunteer.
Okay, yes, we'll do that later. All right, so our A is 1. Is that positive?
Yes.
Yes. Because it's positive, that means our max is infinity. Our H, -7, and that would go here because that means our min is our vertex. That's the lowest point. It's kind of like if you were on a swing set. You know, when you get on a swing, you move in this pattern right here, but where you start, that's the vertex. And then this is -8. All right. All right. -1. So we have a negative. That means our minimum, that means the smallest number it could be would be negative infinity and beyond. I had somebody one time that the only reason that they said, you know, because I was trying to explain that infinity goes on forever. One time they put positive forever and negative forever. And I counted it because that's the way I taught it. It means the same thing. Okay? Some people are like, I'm going to do that. All right, our H would be, so that would go here. And our K,
-4.
Wait, wow. Because it's negative, the one is negative. If you were listening,
ooh, we talking math smack in here?
oh my. You should have heard on the pool yesterday.
Listen, it's always a great day when I have to control people for like talking smack in math, other than like quit licking me and stuff like that. So it's, you know, yes, I've had to deal with that so far this year. All right. So if we go to the back, all right. Shh. This looks confusing, but I promise it gets better. Okay? I promise. So, all this, he knows that's his music. All right. All this is the definition. Okay? I could read that to you, but it's going to make you go to sleep. Okay? So, let's actually apply this. Okay? Let's actually do it. So let's look at this example. What is our A value right here?
+1.
+1. Awesome. All right. What is our K, our H value? Sorry. Okay. This, our H value goes right here in the middle. No, we're going to fill in the chart. We're not going to graph. Okay. Our K is 5. All right. It goes right here. Mm-hmm. Now, if this was a number line, okay, it would look like this across the top. Okay. 1, 2, 3, 4, 5. Okay, like a regular number line, like you would graph. Okay. Now, so now we would say 1 times A. So what is 1 times 1? Okay, so what we do is we take this value, which is 1, we add it to 5. What is 5 plus 1?
6.
6. It goes right here. Yes. Yeah, it goes on both sides because it's symmetric. All right. All right. 3 times 1. Well, that's the wrong color. Awesome. Yes, 3. All right. So that would be, we would add that to 6. So what is 6 plus 3? And that's how we would fill that out. It kind of moves like slope. It goes from this point to this point.
Okay. So whatever you get on that point, you add that.
Yep. Now, I don't expect everybody to understand that after the first one. I think there's another one, and then tomorrow we're going to practice it some more, okay? I really wish I did not know these ratios like this until like 2015. Nobody ever told me this. I really wish I would have done this so I wouldn't have to plug stuff in. All right? So, on this one, this is 2. Let me plug it in here. All right. Our H value is 4. Okay. And remember, it goes here. Escribe por favor en sus papeles ahora. Write this down on your paper right now. All right. And our K goes here. All right. So to find the other things that go beside the H, like if this is 4, this would be 5 and then 6. And this would be 2 and then 3. Okay? So it just kind of fills out like you would see on a number line. Okay? And if you forget what a number line looks like, you could actually Google number line on your Chromebook. Alright? Nope. Alright, I'm trying to do it in the same colors. That's why I went back. Alright. What is 1 times 2? 2. So I'm actually adding 2 to 6. So what is 6 plus 2? 8. Alright. What is 3 times 2? 6. So this would be 6 plus 8, which would be 14. Got 12. Now, you don't add it to the vertex. You go by it's because people added 6 to 6. Yeah, you go from this right here. You add, then you take this and then add. All right. Do we have another one? No. Shh. Huh? Where? Yep. 6 plus 8. So look, let's look at this. So if we put these in,
6 plus 3 is not 8.
shh.
How you get 8?
All right.
3 times 6 is not 8.
Shh. X minus 3 squared plus 5.
You broke your back yesterday. You deserve it.
X minus 3 squared plus 5. All right, so this is that first example we have right here. Okay? This point is our vertex. See this lowest point? 3, 5. All right, if we were to go to the left, this is at, well, yeah, 2, 6. If I could actually get it going the right way. All right. And then if we looked up at number 1, if I can get it to work with me. Okay. it would be 1, 2, 3 up. See, this was 2, 6. Now it's at 1, 9. Okay? That's the way this works. So the other one was what? 2, and then what was it? 4, and then 6. 4. Whoops. Okay, now look at this. Here's our vertex at 4, 6 that we have in the middle of your chart. We go to the reason why y'all are getting more confused, we have more people talking other than what's going on. So all the little side quests and side things going on is going to confuse more people and really going to tick me off. I'm trying to show y'all why the ratio works, but y'all are doing your own thing.